Okay, so in our next video, we are going to go over how to calculate the molecular formula for a compound. Now, if you remember, if we go back to the previous page, we talked about the difference between empirical and molecular formula. So empirical formula is the lowest whole number ratio. The molecular formula is some sort of multiple of that. So this was a multiple of 1. This was a multiple of 2. This was a multiple of 6. So we just need to know what is the actual number of atoms in the compound. What is the molecular formula? Okay, so we're going to try and figure out what's that multiple that I need to multiply by. All right, so again, we have 3 steps here. Where the first is to calculate the mass of the empirical formula, and then we're going to follow through the rest of these examples here, and we're going to follow these 3 steps. Okay, so the first thing is this first example is actually missing a pretty crucial piece of information. So you can just write this in. It should be here. I don't know what happened to it, but it should give you the molar mass of this compound. And the molar mass of this compound is 215.25 grams per mole. All right, so that should have been included in this problem, which it wasn't. Okay, so it says butadiene, the main component responsible for the smell and taste of butter and cheese, contains the elements carbon, hydrogen, and oxygen. The empirical formula for butadiene is C2H3O. So there's our empirical formula. They're already giving it to us. We want to know what is the molecular formula. So it's going to be some sort of multiple of that. If it was a multiple of 2, it might be C4H6O2. Maybe it's a multiple of 5. So maybe it's C10H15O5. It's going to be some sort of multiple. We just need to figure out what that is. All right, so how we do that is step 1, we calculate the mass of the empirical formula. So sometimes this is called the EFM, which just stands for the empirical formula mass. Okay, and again, the empirical formula is C2H3O. That was given. So now I'm going to do 2 times the molar mass of carbon, and I'm going to add that to 3 times the molar mass of hydrogen. And then there's 1 oxygen in this compound, so we're just going to do 1 times 16. Okay, so that should give me the empirical formula mass, which is 43.05 grams per mole. All right, so that's step 1. Find the empirical formula mass. Empirical formula was given. I just look it up off the periodic table. Okay, step 1, check. Step 2, determine the multiple by dividing the molar mass by the empirical formula mass. So I'm going to do molar mass divided by the empirical formula mass. And again, we're just going to call it EFM. So molar mass, that was the part that was supposed to be added to this problem, which is 215. So I'm going to do 215.25 grams per mole divided by the empirical formula mass, which we just found, 43.05 grams per mole. Okay, now I'm just going to divide the two because I want to find what is the multiple. So when I divide these two, I get 5. So that is my magic number. So I'm going to take this 5 and I'm going to go back to the empirical formula and I'm going to multiply each of these individual atoms by 5. So that means my molecular formula is going to be, let's see, C2 times 5, so that's C10, H, 5 times 3 is 15, and O, there's a 1, so times 5, I get 5. So I'm just going to take this number here, and I'm going to multiply it back into the empirical formula. And that will give me my molecular formula. And then step 3 just says multiply every atom in the empirical formula by the multiple, which we just did. Okay, perfect. So that is how we find the molecular formula, which is the actual number of atoms in the compound. Now, let's go from start to finish, because this is a more realistic type of problem where we need to find the empirical formula first, and then we find the molecular formula. So it says succinic acid is a substance produced by lichens, those little plants that grow on rocks. Chemical analysis indicates it is composed of 40.68% carbon. Now remember, I can take that percent and I can just turn it into grams. It's also made up of 5.08% of hydrogen. And then it's also made of 54.24% oxygen. So take the percent and switch it to grams. Now, if you also remember, I'm going to divide by the molar mass because I want to get number of moles. Okay, so I'm going to do the shortcut. I'm just going to divide by the molar mass. I'm not going to show the dimensional analysis here. Divide by the molar mass of hydrogen. Divide by the molar mass of oxygen. So this is going to get me the number of moles. Okay, and when I do that, I get 3.39 moles of carbon. I get 5.03 moles of hydrogen, and then I get 3.39 again moles of oxygen. Okay, so that was the first step in finding the empirical formula, which was on the previous page. We divide by the molar mass, and we get number of moles. Now step 2, if you remember, was to divide by the smallest number, because I need whole numbers here. So I'm going to divide by 3.39, divide by 3.39, and divide by 3.39. So that's going to give me 1. This is going to give me 1. And when I do this, actually I get 1.5. Okay? So step 3 on the empirical formula was, if necessary, multiply by some number to get whole numbers if you still don't have whole numbers. So because this is a 1.5, that's not a whole number, I'm going to multiply everything by 2, and that is going to give me my lowest whole number ratio. All right, which is my empirical formula. So my empirical formula is C2H3O2. Okay, so that's first step. Find the empirical formula, which we just did. Okay, now, to find the molecular formula, remember the first thing we need to do is find the empirical formula mass. So that means I'm going to do 2 times carbon off the periodic table plus 3 times hydrogen plus 2 times oxygen. All right, so that's going to give me my empirical formula mass, and that comes out to be 59.05. And if you remember, we just abbreviated this EFM, empirical formula mass. All right, step 2 on the molecular formula was take the molar mass, which is always given in the problem, and divide it by the empirical formula mass, because we want to find that multiple. So I'm going to do the molar mass, which is given in the problem. It's 118.1 grams per mole. Okay. And then my empirical formula mass, that's what I just found. It's 59.05 grams per mole. So when I divide those two, I get the number 2. That is my multiple. So now I'm going to take that number 2 and I'm going to multiply it back into the empirical formula, and that's going to get me my molecular formula. the actual number of atoms in the compound. Formula. So I get C4H, 3 times 2 is 6, and O, 2 times 2 is 4. So I now have my molecular formula, which again is the actual number of atoms in the compound, and my empirical formula, which is the lowest whole number ratio. All right. So last one. Again, you guys can try this on your own. You can pause the video, try it, and just see if you get the same number. I'm going to go through it pretty quickly. So we've got 30.4 grams of nitrogen and 69.6 grams of oxygen. Step 1, convert it to moles. So divide by the molar mass, 14.01. Divide by the molar mass, 16. So that is going to get me 2.17 moles of nitrogen. And this is going to get me 4.35 moles of oxygen. So step 1, convert to mole. Step 2, divide by the smallest number. So 2.17, 2.17. That comes out to be 1. And this comes out to be 2. So my empirical formula is NO2. Empirical formula. Give me 1 second. I'm almost done. Okay. And then let's see. So we found our empirical formula. So let's do the empirical formula mass. So that's 14.01 plus 2 times 16. So that gives me 46.01. So there's my empirical formula mass. So I'm going to do the molar mass divided by the empirical formula mass. Okay, so this is step 2 on the second part. So let's see. Molar mass is given in the problem. It's 92. Empirical formula mass, 46.01. And I can tell this is going to be 2 when I divide the 2. So I'm going to multiply that back into my empirical formula, and I'm going to get N2O4 is my molecular formula. 1 and 2. All right. I hope that helps.